Hi everyone. Today we're going to be looking at our notes for 2.4, which is average rate of change of a function. To start with the definition, the average rate of change is the of the function y equals f of x between the interval x equals a and x equals b is given as such. It is the change in the output over the change in input, where the change in the output is f of b minus f of a, over the change in the input, which is simply x equals b minus x equals a. Okay, so if we take a look at the graph here, we're looking at the coordinates a, f of a, and b, f of b, and we're taking the change in the output, which is that vertical change here, f of b minus f of a, and that's this vertical distance here, over the horizontal distance, change in inputs, b minus a. So take a moment and think, what mathematical concept does this remind you of? What word can be used as synonymous for average rate of change over an interval? And write your answer below. You may have guessed it. The word that we're thinking of is the slope. So this is similar to finding the slope between 2 points on the graph of a function. So you can go ahead and include in your notes, average rate of change is very similar to the slope of a function of between 2 points of a function. So you can be thinking like change in output over change in input. You can be thinking vertical change over horizontal change, or change in y over change in x is another way we represent this. Okay, let's take a look at a few examples. So here we have the functions f, h, and g given below, where f is the equation, h is the graph, and g is the table of values. These are three different functions. So number one, let's go ahead and find the average rate of f of x, rate of change of f of x between the interval x equals -2 and x equals 4. So to do this, we're going to use our definition, f of b minus f of a all over b minus a. So we have f of 4 minus f of -2 all over 4 minus -2. So in order to find this average rate of change, we have to evaluate the function for both f of 4 and f of -2. So evaluating for f of 4, we plug in 4 into the equation. Well, our equation is x squared minus 5x. So plugging in 4, we have the quantity 4 squared minus 5 times 4, and that's f of 4, minus f of -2. So we're going to plug in -2 into the equation. So we have the quantity -2 squared minus 5 times the quantity -2. And so we have this first grouping is f of 4. The second grouping is f of -2. And that's all over 4 minus -2. Okay, careful with those double negatives. Okay, so now this first grouping we're going to evaluate. This first grouping, we have the quantity 4 squared minus 5 times 4. So 16 minus 20 is -4. Minus f of -2, the second grouping, the quantity -2 squared is 4, positive, minus 5 times -2, or we have 4 plus 10, which is 14. In the denominator, 4 minus -2 is positive 6. Continuing to evaluate, -4 minus 14 is -18, and we have over 6, which reduces to -3. So this is telling us that between the interval from -2 to 4, the function decreases 3 units, 3 units per every unit. So we're saying that the f of x values decrease by 3 for every 1 increase in x values. Okay, let's try number 2. Now we're looking at g of x, which is our table of values. To find the average rate of change, we're going to take g of 5 minus g of 1 all over 5 minus 1. To evaluate g of 5, we just look at the table. So we look at where the x value is 5 and what is the g of x value. That answer is 7. Minus g of 1, so that's where the x value is 1. What's the g of x value? 4. And then over the denominator, 5 minus 1 is 4. 7 minus 4 is 3 over 4. And this is our average rate of change. So between x equals 1 and x equals 5, the function increases 3 units for every 4 units increase x. Okay, let's try two more. Number 3, here we have h of x over the interval 1 to 3. So h of x represents our graph, and we're looking from 1 to 3. So here, h of 1, we go over to x equals 1, and we look where the graph is. We look vertically and see where the graph of the function is. On the y-axis, and we have 2. And then for h of 3, evaluating, that happens to be an x-intercept. So we have the coordinates 3, 0. So finding average rate of change, we have h of 3 minus h of 1 all over 3 minus 1. Well, h of 3 we found to be 0, and h of 1 we found to be 2. And then 3 minus 1 is 2. Evaluating, we get negative 2 over 2, or negative 1. And last but not least, we have back to f of x, which as a reminder is x squared minus 5x. But now we're going to plug in over the interval a to a plus h. And so we're just generalizing this now. So if we plug this in, we have, using our formula, f of a plus h minus f of a. And that's all over the quantity a plus h minus a. Okay. Now you might notice something in the denominator. Here we have a and a negative a, so these can cancel out, and we get f of a plus h, that's an h, there we go, minus f of a all over h. And in fact, this is, we'll see in calculus, this is the definition for a derivative where h approaches 0. So as the quantity h approaches 0, gets closer and closer to 0, this is the definition of a derivative. And we'll learn more about that in calculus. But let's go ahead and plug in the values. So remember, we're evaluating for, or we're simplifying really, for the equation f of x equals x squared minus 5x. So then f of a plus h is equal to, we have the quantity x squared. So we have the quantity a plus h squared minus 5 times x, or 5 times the quantity a plus h. Minus f of a is, we have a squared minus 5a. Okay. And that's all over, again, we just have h in the denominator. So let's go ahead and clean this up a little bit. This first quantity squared, we can use the perfect square trinomial. So this is a squared plus 2ah plus h squared. Don't forget that middle term. And then distributing the negative 5, we get negative 5a minus 5h. And I'm running out of space over here. We have a minus a squared, and then we have a plus 5a. And that's all over h. Now, a couple things we can cancel here. We have a positive a squared and a negative a squared, cancels. We have a negative 5a and a positive 5a, and those cancel. So we're just left with 2ah plus h squared and minus 5h, and that's all over h. Okay. Well, we can factor out or cancel out an h in both the numerator and denominator. So we're left with, and I'm going to rearrange the terms a little bit here. So we have 2a minus 5 and plus h. And then that denominator is canceled out. So we're just left with this expression here. Now, I mentioned that this quantity right here represents, as h approaches 0, this represents the derivative of the function at x equals a. So this expression here, remember, as h approaches 0, then the function, the derivative, is equal to 2a minus 5, again, for x equals a. X equals a. Okay? And so again, once we get to calculus, we'll see how to get from this equation, or this expression, to its derivative, this expression here. We're not going to do a whole lot of examples like this. This was kind of a fun exercise as a challenge in the notes. If you're more comfortable with numbers 1 through 3, you're in a great spot for the notes, okay? This is more like what you're going to be seeing in the notes practice and quizzes, okay? So we're going to get a whole lot of practice on this in class, so we'll see you tomorrow. Have a great day, everybody. Goodbye.